Hello friends, welcome back. Let us solve some questions based on continuity. First of all, see this question. Here the definition of this function fx is given. When x is not equal to 4, then this function fx is equal to this, and when x is equal to 4, then this function fx is equal to 0. Now we have to show that this function fx is continuous everywhere except at x is equal to 4. Now see this definition of this function fx. So when the value of x is not equal to 4, then fx is equal to mod x minus 4 upon x minus 4. So when x is less than 4, then in this case what happens? Fx is equal to what? Fx is equal to mod x minus 4 upon x minus 4. Now here we have assumed that the value of x is less than 4. So x minus 4 will be a negative value. So the mod of x minus 4, it will be equal to minus x minus 4, right? So fx will be minus x minus 4 upon x minus 4, and it is equal to minus 1. So when x is less than 4, fx is equal to minus 1. Fx is equal to minus 1. Now see, when x is greater than 4, in that case also fx is equal to mod x minus 4 upon x minus 4. So here x is greater than 4, right? So x minus 4, it will be a positive quantity, right? So mod x minus 4 in this case will be equal to simply x minus 4. So fx will be x minus 4 upon x minus 4, that is equal to 1. So when x is greater than 4, fx is equal to 1. And when x is less than 4, then fx is equal to minus 1. Right. Now see, when x is less than 4, then fx is a constant function. It is equal to minus 1. So constant functions are continuous. So this function fx is continuous when x is less than 4, right? So fx is continuous when x is less than 4, right? Now see, when x is greater than 4, then fx is equal to simply 1. So here now it is a constant function, right? Here also fx is a constant function when x is greater than 4. So constant functions are continuous. Therefore fx is continuous when x is greater than 4. Now let us see the continuity of this function fx at x is equal to 4, right? So what we need to do now, we have to consider the continuity of fx at x is equal to 4. Now see the definition of the function. Fx is equal to 0 when x is equal to 4, right? So fx is equal to 0 when x is equal to 4. Now we have to consider the continuity of fx at x is equal to 4. So this function fx will be continuous at x is equal to 4 only in the case when limit of fx as x tends to 4 exists and it is equal to f4. So when x is equal to 4, then fx is equal to 0, right? Fx is equal to 0. It means f4 is equal to 0. So this function fx will be continuous at x is equal to 4 when limit of fx as x tends to 4 is equal to f4. It means it is equal to 0, right? So first of all, I need to check whether the limit of fx as x tends to 4 exists or not. So for that purpose, what I need to do, I need to find out its left hand limit as well as its right hand limit. So first of all, I will find its left hand limit, right? Let us find its left hand limit. So what I need to do, first of all, I need to evaluate limit x tends to 4 minus fx, and it is equal to limit h tends to 0 f 4 minus h, right? So f4 minus h, it means the value of x is here less than 4. So according to the definition of fx, right, when x is not equal to 4, fx is equal to mod x minus 4 upon x minus 4. So what happens here, it will be equal to limit h tends to 0 mod 4 minus h minus 4 upon 4 minus h minus 4, right? Because here what is the x? X is 4 minus h. It is not equal to 4. So according to the definition, f4 minus h is equal to this. Now it is equal to what? It is equal to limit h tends to 0 mod minus h upon minus h, right? And it is equal to limit h tends to 0 h upon minus h, and it is equal to minus 1. This is the left hand limit. Now let us consider the right hand limit. Right, so what would be the right hand limit? It is limit x tends to 4 plus fx, and it is equal to limit h tends to 0 f 4 plus h. So again, according to the definition of fx, it will be equal to what? f4 plus h will be equal to mod 4 plus h minus 4 upon 4 plus h minus 4, right? And it will be equal to limit h tends to 0 4 plus h minus 4, it is equal to what? It is equal to mod h, right? And 4 plus h minus 4 is h. So it is equal to limit h tends to 0 h upon h is equal to 1. So here you can see that left hand limit of fx at x is equal to 4 is not equal to the right hand limit of fx at x is equal to 4. So it means limit of fx as x tends to 4 does not exist, right? What does it mean? It means that limit of fx as x tends to 4 does not exist. So it means that, it implies that function fx is not continuous at x is equal to 4. So in this question I have shown that this function fx is continuous when x is less than 4. This function is also continuous when x is greater than 4, but this function is not continuous when x is equal to 4. So it means that this function fx is continuous everywhere except when x is equal to 4, except that x is equal to 4. Now let us solve one more question like this. So The next question is, this function fx is given to us sine 2x upon x when x is less than 0 and x plus 2 if x is greater than or equal to 0, right? Now we have to discuss its continuity. Now we have to discuss the continuity of this function. So let us see here. According to the definition of this function, when x is less than 0, then fx, it is equal to what? It is equal to sine 2x upon x. It is equal to sine 2x upon x. Now see here, x, right? X is everywhere continuous, and sine 2x, it is also everywhere continuous. So when two functions gx and hx, when these two functions are continuous, then gx upon hx is also continuous. So sine function and x is this function x, they both are continuous everywhere. So sine 2x upon x, this will also be continuous, right? So when x is less than 0, then this function fx is continuous. So it implies fx is continuous when x is less than 0. Now see the another condition. When x is greater than 0, when x is greater than 0, in this case what happens? In this case fx is equal to x plus 2. It is a polynomial function, right? Right now what happens? This fx is a polynomial function. So for this polynomial function is a continuous, right? We know that it is the property that polynomial functions are continuous. So when x is greater than 0, fx is continuous. So fx is continuous when x is greater than 0. Now let us discuss the continuity of this function fx at x is equal to 0. So what we need to do? We need to consider the continuity of this function fx at x is equal to 0, right? Now we need to do this thing. So okay, now see the definition of function fx. So when x is equal to 0, fx is equal to x plus 2. Fx is equal to x plus 2 when x is equal to 0, right? So this function fx will be continuous at x is equal to 0 when limit of fx as x tends to 0 is equal to f0, right? So let us see the limit of function fx as x tends to 0. First of all, we will consider its left hand limit. So its left hand limit will be limit x tends to 0 minus fx, and it is equal to limit h tends to 0 f0 minus h. So see the definition of function fx. when x is less than 0, fx is equal to sine 2x upon x. So f0 minus h is equal to what? Sine 2 0 minus h upon 0 minus h, right? And it will be equal to limit h tends to 0 sine minus 2h upon minus h. And we know that sine minus x is equal to minus sine x. Therefore, this expression will be equal to minus limit h tends to 0 sine 2h upon minus h. This minus will cancel this minus. Now what we will do, we will multiply numerator and denominator both by 2, right? So now we have what I have, limit h tends to 0 sine 2h upon 2h into 2. So as h tends to 0, 2h also tends to 0. So this term will be equal to 1, right? We know that there is a property. What is that property? Limit x tends to 0 sine x upon x is equal to 1, right? So here I have applied this property, so this term will be equal to 1. So here, as you can see, h tends to 0, therefore 2h also tends to 0, right? So since limit 2h tends to 0 sine 2h upon 2h, it will be equal to 1. So now this expression, this complete expression will be equal to 1 into 2, that is equal to 2. So left hand limit is 2. Left hand limit of fx at x is equal to 0 is 2. Now I have to consider the right hand limit. I need to check the right hand limit of fx at x is equal to 0. So let us see its right hand limit. First of all, see, when x is greater than 0, fx is equal to x plus 2, right? So in this case, what happens? It will be equal to limit h tends to 0 f0 plus h, and it is equal to limit h tends to 0 plus h plus 2, and it will be equal to 2, right? So here we can see that left hand limit is equal to 2 and right hand limit is also equals to 2. So limit of fx, here I will write limit of fx as x tends to 0 is equal to 2. Now what is f0? So when x is equal to 0, fx is equal to x plus 2, right? So f0 will be 0 plus 2, that is equal to 0. So limit of fx as x tends to 0 is equal to f0. It means this function fx is continuous at x is equal to 0, right? So here I have proved that this function fx is continuous when x is less than 0. This function is also continuous when x is greater than 0. And here now I have proved this function fx is also continuous at x is equal to 0. So it means that this function fx is continuous everywhere. So here we have proved that this function fx is continuous everywhere. Now let us solve one more question like this. The next question is, discuss the continuity of the function fx is equal to mod x upon x if x is not equal to 0, is equal to 0 if x is equal to 0. Now we have to discuss its continuity. Now see, first of all we will consider the case when x is less than 0. So what happens when x is less than 0? In that case, fx will be equal to, since x is less than 0, it will be a negative term, right? So and mod x will be minus of x, right? So fx will be minus x upon x, that is equal to minus 1. So now fx is equal to minus 1. It is a constant function and constant functions are continuous. So in this case what happens? Fx is continuous. So when x is less than 0, fx is continuous. Now let us see what happens when x is greater than 0. When x is greater than 0, then fx is equal to mod x upon x, right? So here now x is a positive quantity, so mod x will be equal to x, so it will be equal to, fx will be x upon x is equal to 1. So now here again fx is a constant function and constant functions are continuous. Therefore when x is greater than 0, fx is continuous. Okay, now next step, we have to consider the continuity of this function fx at x is equal to 0. So when x is equal to 0, fx is equal to 0 according to the given definition of fx. Now we have to consider the continuity of this function fx at x is equal to 0. So this function fx will be continuous at x is equal to 0 if limit of fx as x tends to 0 exists and it is equal to f0. So f0 is equal to what? It is equal to 0. So first of all I will check whether the limit of fx as x tends to 0 exists or not. So first of all, for that purpose I will find its left hand limit. So what is the left hand limit? Limit x tends to 0 minus fx, and it is equal to limit h tends to 0 f0 minus h. So when x is not equal to 0, fx is equal to what? It is equal to mod 0 minus h upon 0 minus h, and it will be equal to limit h tends to 0 h upon minus h is equal to minus 1. So left hand limit is equal to minus 1. Now let us consider right hand limit. So right hand limit is what? Limit x tends to 0 plus fx, and it is equal to limit h tends to 0 f0 plus h, right? Okay, again the definition of function fx it will be equal to limit h tends to 0. So according to the definition of function f(x), f0 plus h will be mod 0 plus h upon 0 plus h, and it will be equal to limit h tends to 0, h upon h is equal to 1. So now you can see here that limit of f(x) as x tends to 0 does not exist, because its left hand limit at x is equal to 0 is not equal to right hand limit when x is equal to 0, right? Left hand limit of f(x) when x is equal to 0 is not equal to the right hand limit of f(x) when x is equal to 0. So it implies that what? Limit of f(x) as x tends to 0 does not exist, right? Because left hand limit is not equal to right hand limit, so this limit does not exist. So hence this function f(x) is not continuous at x is equal to 0. So this function f(x) is continuous when x is less than 0. It is also continuous when x is greater than 0, but it is not continuous at x is equal to 0, right? So this function f(x) is continuous at each point except x is equal to 0, right? Now there is one more question like this. It is little bit typical. Now we will solve that question also. Now let us solve this question. This question is, determine the value of constant k so that this function f(x) is continuous. See the definition of this function f(x). f(x) is equal to kx square, right? f(x) is equal to kx square when x is less than equal to 2, and f(x) is equal to 3 when x is greater than 2. Now let us solve it. So see, when x is greater than 2, f(x) is equal to 3, which is a continuous function, because f(x) is equal to 3 is a constant function, and constant functions are continuous. It is the property which we studied in previous video. So f(x) is equal to 3. This function f(x) is continuous. So when x is greater than 2, then the function f(x) is continuous. So f(x) is continuous when x is greater than 2. Now next is, what happens when x is less than 2, right? When x is less than 2, f(x) is equal to kx square, right? Then f(x) is equal to kx square according to the definition of f(x). Now it is a polynomial function, and polynomial functions are also continuous. So f(x) is continuous when x is less than 2. Now let us see the continuity of this function f(x) at x is equal to 2. So this function f(x) will be continuous at x is equal to 2 if and only if at x is equal to 2, fx is continuous if and only if limit of fx as x tends to 2 is equal to f2. So limit of fx as x tends to 2, right? We need to check whether the limit of fx as x tends to 2 exists or not. For that we need to evaluate its left hand limit and right hand limit, right? So see, first of all see its left hand limit. Limit x tends to 2 minus fx is equal to limit h tends to 0 f2 minus h. So when x is less than 2, fx is equal to x square. So f2 minus h will be equal to k 2 minus h square. Now see, right hand limit. Limit x tends to 2 plus fx is equal to limit h tends to 0 f2 plus h. Now when x is greater than 2, fx is equal to 3. So it will be equal to 3. Simple. So first of all, this function will be continuous at x is equal to 2 when left hand limit is equal to right hand limit, right? When left hand limit is equal to right hand limit. So this is the left hand limit. So here it is equal to what? It is equal to 4k, right? So left hand limit should be equal to right hand limit, otherwise limit of fx as x tends to 2 will not exist and the function will not be continuous at x is equal to 2. So 4k should be equal to 3. That implies k should be equal to 3 by 4, right? K should be equal to 3 by 4. So limit of fx as x tends to 2, it is what? It is 3, because you can see here left hand limit and right hand limit, though both are equal to 3. So limit of fx as x tends to 2 is 3. Now what is the value of f2, right? So f2 is when x is equal to 2, fx will be kx square, and kx square, it means it will be k into 2 square, and k is what? It is 3 by 4 into 2 square is 4, is equal to 3. So here you can see that when k is equal to 3 by 4, limit of fx as x tends to 2 is equal to f2. It means this function fx is continuous at x is equal to 2 when k is equal to 3 by 4. And this function, as I have already proved, it is continuous when x is greater than 2, and it is also continuous when x is less than 2, right? So this function will be continuous everywhere when k is equal to 3 by 4.